All right. Hello, everyone. If you're getting ready for your computer networks exam, or you're just starting out and trying to figure out how this all works, you are in the perfect spot. We're going to go through the first couple of weeks of NPTL's course and break it all down, nice and simple. Let's get right into it.
So, have you ever really thought about it? You take a picture, tap send, and boom, it's on your friend's screen, maybe thousands of miles away. It honestly feels like Margit, right? But it's not. It's actually a system, a really, really smart system with a set of rules that makes this happen millions of times a second all over the world.
And the absolute heart of that system is something called a protocol. Now, don't let the word scare you. A protocol is just a rule book. That's it. It's a shared language that every device, your laptop, your smart TV, your phone, agrees to use so they can all understand each other. It's the foundation for everything we're about to talk about. Okay, so here's our game plan for this little revision session. We're going to start with why we need a system for sending messages at all. Then we'll look at the blueprint for that system. After that, we'll see how data gets all packed up for its big trip. We'll meet some of the most important protocols, the real workers of the network. And finally, we'll talk about the difference between your Wi-Fi at home and the giant internet itself. So, first things first, why the need for this big, complicated system? Well, think about trying to mail a letter without a postal service. No addresses, no stamps, no mail carriers. Total chaos, right? It would never get there. The internet would be exactly the same without what we call a network architecture. It's the master plan that makes sure our digital messages don't just get lost in space. So how do you manage a task as gigantic as connecting the entire planet? You do what any good engineer does. You break the problem down into smaller, manageable pieces, or layers. It's kind of like an assembly line for data. Each layer has one specific job to do, and the two blueprints or models you absolutely need to know are called the OSI model and the TCP/IP model. Okay, let's look at these two side by side. On the left, you see the OSI model. It has 7 layers. Think of this as the perfect, ideal textbook theory. It's a great way to learn and understand all the steps. On the right, we have the TCP/IP model. It's a bit more streamlined, and here's the key. This is the one the internet actually runs on. It's the practical, real-world version that won out. Now, okay, big exam alert here. This table, you're going to want to know it. You will almost certainly be asked about the 7 layers of the OSI model. For now, just get the main idea. Up at the top, layer 7, the application layer. That's the stuff you see, like your web browser. All the way down at the bottom, layer 1, the physical layer, that's the actual wires and radio waves, the real physical stuff. So we have our blueprint, this layered model, but how does your data, like a photo, actually travel through it? This brings us to a super important process called encapsulation. The best way to get this is to go back to our digital postal service idea. It's all about how we package something to make sure it gets where it's going. So what is encapsulation? It's simply the process of wrapping your data with extra information at each layer. As your data goes down the layers, each layer adds its own little label called a header. It's literally like writing a letter, putting it in an envelope with an address, and then putting that envelope inside a bigger shipping box with another label on it. Same idea, just digital. Now, I know this diagram looks a bit busy, but it shows this wrapping process perfectly. See up there at the top? You start with your user data. As it goes down to the transport layer, it gets a TCP header wrapped around it. Then it goes down to the network layer and boom, an IP header gets added. Then the data link layer adds its own wrapper. Each step adds another layer of packaging.
Let's just walk through it one more time. Your data starts at the top. The transport layer wraps it and calls the new package a segment. Then the network layer wraps that and calls it a packet. Then the data link layer wraps it again and calls it a frame. These are just names for the package at different stages of its journey. Finally, the physical layer turns the whole frame into electrical signals or light pulses to send it on its way.
Okay, so we've got the blueprint, the layers, and we have the process, encapsulation. But who are the actual workers doing the jobs at each layer? Well, now it's time to meet some of the most important protocols. At the transport layer, you have 2 famous workers, TCP and UDP. And listen up, because this is another huge topic for exams. TCP is the reliable one. Think of it like a registered package with tracking. It makes sure every single piece arrives in the right order. That's why we use it for email or websites. You need all the data to be perfect. UDP, on the other hand, is all about speed. It's like a regular postcard. You just send it and hope for the best. It's way faster, which is why it's great for video streaming or online games, where a tiny glitch you don't even notice
is better than a long delay.
Next up, DNS. The easiest way to think of the domain name system is as the phone book for the entire internet. You and I remember names like Google.com, but computers, they prefer numbers, these long strings called IP addresses. DNS is the amazing service that looks up the name you type and finds the right number for the computer. It's also what gives us the endings like .com, .edu for education, or .gov for government.
And another worker you should know is FTP, the File Transfer Protocol. The name pretty much gives it away, right? Its whole job is to move files from one computer to another. And because you want your files to arrive without any mistakes, it uses our reliable friend TCP to get the job done.
Okay, we've talked about the data packages and the protocols that handle them. But what about the roads that all this traffic travels on? Let's zoom out a bit and look at the difference between the small neighborhood streets and the giant global highways of the internet.
So we have LANs and WANs. A LAN, or local area network, is exactly what it sounds like, local. It's the network in your house or in one office building. It's small, it's private, and you usually own the gear, like your Wi-Fi router. A WAN, or wide area network, is the big one. It connects different LANs together over a massive area, like across a country or even between continents. This is the internet itself. You don't own it, you just rent access to it from a provider.
Whew, okay, that was a pretty quick tour through the basics, I know, but you've got this. To make sure it all sinks in, let's just do a super fast recap of the most important points we covered. So what do you need to remember? Number 1, networks use layers, like a blueprint, and the big ones are OSI and TCP/IP. 2, encapsulation is just wrapping the data in headers for its trip. 3, TCP is reliable, UDP is fast. 4, DNS is the internet's phone book. And 5, LANs are the small local networks, and WANs are the giant networks that connect them all.
All right, one last time. Exam alert! If you're studying for your test, these next few topics are the ones you really want to spend some extra time on. These are the fundamentals that always come up.
Okay, get ready. First, you absolutely need to know the 7 layers of the OSI model and have a basic idea of what each one does. Second, be ready to explain why we use the TCP/IP model instead of the OSI model. Third, make sure you can describe that whole process of encapsulation step by step. And finally, you have to be able to explain the difference between TCP and UDP like the back of your hand.
So, feeling a little more confident? The absolute best way to lock this information in your brain is to try and use it. So, let's try a few practice questions, the kinds you might actually see on your exam. Here we go. I'll read them out, and I really want you to pause and try to answer them yourself. Question 1, can you explain the function of each layer in the OSI model? 2, what is encapsulation, and why do we even need it? 3, compare TCP and UDP, and when would you use one versus the other? 4, describe the difference between a LAN and a WAN. And number 5, what is the role of DNS? So the next time you click a link or send a message, just take a second to think about the incredible, invisible journey that your data is taking. It's traveling through layers, getting wrapped up, and being guided by all these amazing protocols. Every single click is a little masterpiece of communication. Thanks for listening, and good luck with your studies.